Hello students, welcome to Breedmark Academy. Myself LS Nanda. I have carefully selected 75 questions from JEE Main Entrance exam that was conducted in the month of January this year. I will be making 3 videos on detailed solutions of these 75 questions. In each video, I will be discussing 25 questions. In my opinion, any student who is going to appear for JEE Main Entrance exam in the future must practice these problems. If you can try all the problems asked in all the shifts, it would be better. But if you find shortage of time, then at least these questions you must practice. Now, this is the first question, and you can clearly see it's a problem based on the topics of ellipse and hyperbola. It says, let E x square upon a square plus y square upon b square equal to 1, where a is greater than b, and h x square upon capital A square minus y square upon capital B square equal to 1. Let the distance between the foci of E and foci of H be 2 root 3 if small a minus capital A equal to 2, and the ratio of the eccentricities of E and H is 1 upon 3, then the sum of the lengths of their latest rectums is equal to. Now students, you can clearly see it's a problem based on the basic concepts of ellipse and hyperbola. Now, since this is the ellipse where a is greater than b, so it's a horizontal ellipse. And we have been given the distance between its foci as 2 root 3. So it means 2 into a into e is equal to 2 root 3, which means AE is equal to root 3. Now similarly, we have been given the distance between the foci of the hyperbola as 2 root 3, which means 2 into capital A into E dash is equal to 2 root 3, where E represents the eccentricity of ellipse and E dash represents the eccentricity of the hyperbola, right? So from this equation we get capital A into E dash equal to root 3. Now students, we can clearly see A into E is equal to capital A into E dash. So this means E upon E dash is equal to capital A upon small a. And we have been given the ratio of the eccentricities of ellipse and hyperbola as 1 upon 3. So this means that small a equal to 3 times capital A. Fine. Now the next equation which is given to us is small a minus capital A equal to 2. So just replace small a by 3 times capital A in this equation. So you will be getting 2 times capital A equal to 2 or capital A equal to 1. Now since capital A is equal to 1, put this value over here. You will be getting small a equal to 3. Right? Now students, if I put the value of small a as 3 in this equation, I will be getting E equal to 1 upon root 3. That means the eccentricity of the ellipse is 1 upon root 3. And if I put the value of capital A as 1 in this equation, I will be getting the eccentricity of the hyperbola as root 3. So that means now we have got the eccentricities of both of them. Let's move further. Now students, we know that E square is equal to 1 minus B square upon A square. The value of E is 1 upon root 3. So it becomes 1 upon 3 equal to 1 minus B square upon A square is going to be 9 because A was 3. So from here we get B square upon 9 equal to 2 upon 3, or B square becomes equal to 6. So that means the length of the latest rectum of ellipse becomes how much? It becomes 2B square by A, which is nothing but 2 into 6 upon 3. So this becomes 4, right? Now we move towards hyperbola. We know that E dash square is equal to 1 plus B square upon A square. Fine. The value of E dash was root 3. So this is 3 equal to 1 plus B square upon 1 because capital A was 1. So from here we get the value of B square equal to 2. Now students, length of latest rectum of hyperbola is going to be how much? It is again to capital B square upon A. And this is nothing but 2 into 2 upon 1, which is again 4. So that means the sum of the lengths of latest rectum of both of them is going to be 8. So this is the right answer. So that means option D is correct. Now students, we move towards the next question. Now students, this is the next question. It says, suppose that the number of terms in an AP is 2k, where k is a natural number. If the sum of all odd terms of the AP is 40, the sum of all even terms is 55, and the last term of the AP exceeds the first term by 27, then k is equal to. Now students, it is mentioned that the number of terms in this AP is 2k, which is an even number. So this clearly means that there will be exactly k terms which will be called the odd terms of the AP, or they will be occurring at the odd positions of the AP. And similarly, there will be exactly k terms which will be called even terms of the AP, or they will be occurring at even positions of the AP. Now, if I consider A1, A2, A3 and so on up to A2k as the original AP, then the sequence formed by the odd terms is going to be A1, A3, A5 and so on till A2k minus 1. Now clearly this is again going to be an arithmetic progression. Why? Because the difference of its consecutive terms is same, as A3 minus A1 will be equal to A5 minus A3 will be equal to A7 minus A5 and so on. And this particular difference will be just equal to 2 times the common difference of the original AP, right? Now similarly, the sequence formed by the even terms, that is A2, A4, A6 and so on till A2k, will also be an arithmetic progression, right? And it will have the same common difference as 2D. Fine. Now students, we know the formula to find the sum of the AP, and it is mentioned that the sum of the first sequence, that is the sum of all odd terms, is 40. So I can write k by 2 into 2a1 plus k minus 1 into 2d equal to 40. And similarly, I can write the sum for all even terms. It becomes k by 2 into 2 times a1 plus d plus k minus 1 into 2d equal to 55. Now students, if I call this as equation number 1 and this as equation number 2, and if I subtract equation 1 from equation 2, then what do I get? I will be getting k by 2. Inside the bracket, I will be getting just 2d. And this is equal to 15. So it means the value of kd is equal to 50. Now this is our equation number 3. Now we move further. Now students, it is given that the last term of the AP, which is A2k, exceeds the first term by 27. So that means A2k minus A1 equal to 27. A2k can be written as A1 plus 2k minus 1 into D. So from here, what do we get? We will be getting 2k minus 1 into D equal to 27. This can be written as 2kd minus d equal to 27. Now if I use the equation number 3 and put the value of kd over here, I will be getting 2 times 15 minus d equal to 27, or d becomes equal to 30 minus 27, which is equal to 3. Now since kd is equal to 15, if I put the value of d over here, I will be getting the value of k as 5. So that means option C is the correct one. Now we move to the next question. Now students, this next question is based on the topic of indefinite integration. It says if integral e power x into inside the brackets x into sine inverse x divided upon square root of 1 minus x square plus sine inverse x divided upon 1 minus x square whole power 3 by 2 plus x upon 1 minus x square dx equal to gx plus c, where c is the constant of integration, then g of half equals. That means we have to find the value of g of half. Now students, clearly this problem is based on one very important type of indefinite integral, and that is integral e power x into inside the bracket fx plus f dash x dx equal to e power x into fx plus c. Now, if I consider this particular function, that is x into sine inverse x divided upon square root of 1 minus x square as fx and find its derivative, then what do I get? F dash x becomes equal to, in the denominator I will be having 1 minus x square, and in the numerator I will be having square root of 1 minus x square into inside the brackets I will be having sine inverse x plus x upon square root of 1 minus x square bracket close minus x into sine inverse x into 1 upon 2 into 1 minus x square whole power minus half into minus 2x. Now students, just do the calculations and simplify this expression. In the denominator, we will be having 1 minus x square whole power 3 by 2. And in the numerator, we will be having x into square root of 1 minus x square plus 1 minus x square into sine inverse x plus x square into sine inverse x. Just simplify it further. Finally, you will be getting x into square root of 1 minus x square plus sine inverse x whole divided upon 1 minus x square whole power 3 by 2. Now, if you just separate these two terms, you are going to get sine inverse x upon 1 minus x square whole power 3 by 2 plus x upon 1 minus x square. So that means if this function is fx, then this particular remaining function is f dash x. Now it has clearly taken the shape of e power x into fx plus f dash x dx. So answer is very much obvious now. It is going to be e power x into fx. Fine. Now we move further. Now students, the value of the integral becomes e power x into sine inverse x divided upon square root of 1 minus x square plus c. Now clearly we can say gx equal to e power x into sine inverse x divided upon square root of 1 minus x square. Now since we want to get the value of g of half, so just put x equal to half on both the sides. So g of half becomes e power half into 1 by 2 into sine inverse half divided upon square root of 3 by 4, which is just root 3 by 2. So upon simplification, it becomes square root of e by 3 into sine inverse half, and sine inverse half is pi by 6. So that means it is pi upon 6 into square root of e by 3. So that means option B is the correct one. Now students, we move towards the next question. Now students, this next question is based on the topic of permutations and combinations. It says in a group of 3 girls and 4 boys, there are 2 boys B1 and B2. The number of ways in which these girls and boys can stand in a queue such that all the girls stand together, all the boys stand together, but B1 and B2 are not adjacent to each other is. Now in order to solve this problem, what we will do, we will first find the total number of ways in which these 7 children can be arranged among themselves in a queue such that 3 girls are standing together and 4 boys are standing together. And then from this value, we will subtract the number of ways of arranging these 7 children in a queue such that 3 girls are standing together, 4 boys are standing together, but at the same time, B1 and B2 are adjacent to each other. That means after finding the total number of cases, we will subtract the unwanted cases to get the number of wanted cases. Fine. Now students, we will be using block method because we have to keep all the girls together and all the boys together. So in one block, I am placing all the girls, and in another block, I am placing all the boys. G1, G2, G3 These are girls. B1, B2, B3, B4 are boys. Now these girls can be arranged among themselves in this block in factorial 3 ways, and this particular block has 4 boys. So these 4 boys can be arranged among themselves in factorial 4 ways, and then we can permute these two blocks among themselves in factorial 2 ways. Fine. So if I call this value as n1, then n1 comes as 288. Right? Now students, we find the number of unwanted cases. Now in this situation, all the girls are together as before. All the boys are together, but B1 and B2, they are adjacent to each other. So that means I will introduce another block inside this previous block, right? Now these girls can be permuted among themselves in factorial 3 ways, but this time I do not have 4 items in the second block. I am having only 3 items because B1, B2 I have to treat as a single unit. Fine. So these boys can be permuted among themselves in factorial 3 ways, and then inside this particular block we have 2 items, that means 2 boys. So they can be permuted among themselves in factorial 2 again, and these 2 blocks can be permuted among themselves again in factorial 2 ways. So when you solve this value n2 comes as 144. So now our answer is n1 minus n2, and that is equal to 144. So hence option A is the correct one. Now students, we move towards the next question. Now students, this question is on parabola. It says let P 4, 4 root 3 be a point on the parabola y square equal to 4ax and PQ be a focal chord of the parabola. If M and N are the foot of perpendiculars drawn from P and Q respectively on the directrix of the parabola, then the area of the quadrilateral PQNM is equal to. Now we know that the equation of the directrix of the parabola y square equal to 4ax is x equal to minus a, right? Now suppose this is the parabola and this is its directrix x equal to minus a. Now there is a point P 4, 4 root 3 lying on this parabola, and from this particular point we are dropping a perpendicular PM onto the directrix. And this is the focal chord PQ. That means this particular chord is going to pass through the focus of the parabola, which is a, 0. Fine. And from this point Q, we are dropping another perpendicular onto the directrix of the parabola. This is QN. Now clearly, since PM is parallel to QN, so the figure PQNM is going to be a trapezium because one pair of opposite sides is parallel. Fine. Now students, since the point 4, 4 root 3 is lying on the parabola, so it must satisfy its equation. So I can substitute y as 4 root 3 and x as 4 in the equation of the parabola. So from here, what do I get? I will be getting 48 divided upon 16 equal to a, or a equal to 3, right? Now we have got the value of a. We also know that 80 square comma 280 represents the parametric coordinates of any point lying on the parabola, right? So that means if I use 280 equal to 4 root 3 to find the parametric value t for the point P, then the value of t will come as 4 root 3 divided upon 2a. 2a means 2 into 3. So this finally becomes 2 upon root 3, right? Now we move further. Now students, let me make the figure again. Now we know that the value of a is equal to 3. So that means the equation of the parabola will be x equal to minus 3. Now we have the focal chord PQ, where the coordinates of P are 4, 4 root 3. But we do not know the coordinates of the point Q. We will have to find them. This is the perpendicular QN, and this is the perpendicular PM, right? Now students, if you have studied parabola thoroughly, then you must be knowing that if t and t dash are the parametric values of two endpoints of the focal chord of the parabola y square equal to 4ax, then t into t dash is equal to -1. So that means t dash is equal to -1 upon t. Now here t refers to the parametric value for the point P and q refers to the parametric value for the point Q. So that means t dash is going to be -1 upon t, and t we have found as 2 upon root 3. So it becomes minus root 3 upon 2. Now students, we can easily find the coordinates of q because they are going to be 80 dash square comma 280 dash. So just put in the values. So it becomes 3 into 3 by 4 comma 2 into 3 into minus root 3 upon 2. So the coordinates of q become 9 by 4 comma minus 3 root 3. Clear? Now this is the point 9 upon 4 comma minus 3 root 3. Now students, we know that the area of the trapezium is given by the formula half h into a plus b, where h refers to the distance between the parallel sides and a and b are the lengths of the parallel sides. And in the figure, we have the parallel sides as PM and QM. So the value of PM is nothing but this distance is 3 and this is 4. It will be 7. And the value of QN we can find as 3 plus 9 upon 4. Right? So this becomes 21 upon 4. Now, how to find the value of Mn? Now let me call this point as L. Now students, the ordinate of M will be same as the ordinate of the point P. Why? Because PM is parallel to the x-axis. So that means length LM will be 4 root 3. And similarly, I can say the length LN will be 3 root 3. So if I add both of them, the value of Mn becomes 7 root 3. Now let us find the area. It becomes 1 upon 2 into 7 root 3 into 7 plus 21 upon 4. So it becomes 7 root 3 by 2 into, just do the calculations, it becomes 49 by 4. And finally, this is 343 into root 3 divided upon 8. So that means the option B is the correct one. Now students, we move further. Now students, this question is based on the topic of probability. It says if A and B are two events such that PA intersection B equal to 0.1 and PA by B and PB by A are the roots of the equation 12x square minus 7x plus 1 equal to 0, then the value of PA complement union B complement divided upon PA complement intersection B complement is. Now the expression which we have to find can be written as PA intersection B whole complement divided upon PA union B whole complement. I have just used De Morgan's law. Now the numerator can further be written as 1 minus PA intersection B divided upon denominator can be written as 1 minus PA union B. Right? Now students, the value of the numerator can be easily found by subtracting 0.1 from 1. That means this is just 0.9. And in the denominator, we will have to use the formula for PA union B. So this is PA plus PB minus PA intersection B. Now we have the value of PA intersection B, but we do not have the value of PA plus PB. So to find this value, we have been given additional information, and that is PA by B and PB by A are the roots of this equation. So just get the roots of this particular equation. So the roots of this equation come as 1 by 4 and 1 by 3. Now you can assume any value among these to be PA by B. That means you can either take PA by B as 1 by 3 or 1 by 4. That is your choice, because it is not going to affect the answer of the question. Now PA by B I am taking as 1 upon 4 and PB by A I am taking as 1 upon 3. Now the formula for PA by B is PA intersection B upon PB. Fine. Now students, we have been given the value of PA intersection B as 0.1. So that means from here I get the value of PB as 0.4. Similarly, PB by A can be written as PA intersection B upon PA. And this is 1 upon 3. So it means the value of PA will be 0.3. Fine. So from here, what do we get? We get the value of PA plus PB as 0.7. Fine. Now students, we move further. Now students, just put in the values in the given expression. So the answer becomes 0.9 divided upon 1 minus 0.7 minus 0.1. So this is how much? It is 0.9 divided upon 0.4, or finally this is 9 upon 4. So that means option D is the correct one. Now we move to the next question. Now students, this question is based on the topic of limits. It's a nice question. It says, if limit extending to infinity inside the bracket e upon 1 minus e, another bracket starts 1 upon e minus x upon 1 plus x, both brackets closed, whole power x equal to alpha, then the value of log of alpha to the base e divided upon 1 plus log of alpha to the base e equals. Now it's an interesting question, and when we put x as infinity in this particular limit, then the form of the limit comes as 1 to the power infinity. And students, you must be knowing that in order to solve the limits of this particular form, we use the formula of the limits. Limit fx tending to 0, 1 plus fx, whole power 1 upon fx equal to e. So this is the formula that we are going to use. Now, first of all, inside the bracket, we are getting 1. But how to create fx? So what do? We rewrite this limit as limit x tending to infinity. Now, I will be adding 1 and subtracting 1. So I will be getting 1 plus e into 1 minus e into, inside the bracket, 1 upon e minus x upon 1 plus x, and then minus 1. And then I will put another bracket, right? Whole power x. So this is the expression that you have to create. Now, this particular term we will be calling as fx, because this particular function will approach 0 when x approaches infinity, right? Now, this is fx. Let's simplify this. It is e upon 1 minus e into, inside the bracket, it is 1 upon e minus x upon 1 plus x, and then minus 1. So what I do, I take out e upon 1 minus e common. Now inside the bracket, I will be getting 1 upon e minus x upon 1 plus x minus 1 minus e upon e. Right? Now students, we solve it further. It becomes e upon 1 minus e. And now inside the bracket, I will be getting 1 by e minus 1 by e plus 1, which comes to just 1, minus x upon 1 plus x. Right? Now, further we can write this as, now students, the value of fx becomes equal to e upon 1 minus e into, inside the bracket, it is going to be 1 plus x minus x divided upon 1 plus x. So this is nothing but 1 upon 1 plus x. And this finally becomes e upon 1 minus e into 1 plus x, right? Now the value of alpha is limit x tending to infinity, fx tending to 0, 1 plus fx whole power x. Now to use the formula that I have mentioned, I will be rewriting this limit as limit x tending to infinity, fx tending to 0, 1 plus fx whole power 1 upon fx into x into fx. Now students, we know that limit x tending to infinity 1 plus fx whole power 1 upon fx can be written as e. So alpha becomes equal to e to the power limit x tending to infinity, fx tending to 0, x into fx. Fine. Now just put the value of fx over here. It becomes e to the power limit x tending to infinity, x into e upon 1 minus e into 1 plus x. Now just take out e upon 1 minus e common from the limit. Now it becomes e to the power e upon 1 minus e into limit x tending to infinity, x upon 1 plus x. Now in order to solve this limit, just divide up and down by x. So this becomes 1 upon x plus 1. Now students, when x is approaching infinity, obviously 1 upon x will approach 0. So the value of limit or the value of alpha comes as e to the power e upon 1 minus e. Fine. Now students, we have to evaluate log of alpha to the base e divided upon 1 plus log of alpha to the base e. Now since alpha we have already got, so from here I can say log of alpha or ln alpha is equal to e upon 1 minus e. Now we will find the value of the required expression. Now students, we have to evaluate the expression ln alpha divided upon 1 plus ln alpha. And ln alpha we have got as e upon 1 minus e. So just put its value over here. And now simplify it. It becomes e upon 1 minus e plus e. And this is nothing but e. So that means option C is the correct one. Now students, we move towards the next question. Now students, this question is based on the geometry of complex numbers. It says, let the curve z into inside the bracket 1 plus iota plus z bar into inside the bracket 1 minus iota equal to 4, where z is a complex number, divide the region mod of z minus 3 less than or equal to 1 into two parts of areas alpha and beta, then mod of alpha minus beta equals. Now to solve this problem, first of all, we will be putting z equal to x plus iota y inside this equation. Just to simplify this equation. Now, when I put z as x plus iota y, it becomes x plus iota y into 1 plus iota plus x minus iota y into 1 minus iota equal to 4. Now just open up the brackets. You will be getting x into inside the bracket 1 plus iota y plus iota square y, which is nothing but minus y because iota square is equal to minus 1, plus x into inside the bracket 1 minus iota y minus y equal to 4. Now students, when you add all the terms, you will be getting 2x minus 2y equal to 4 or just x minus y equal to 2. So that means this represents a straight line. Now, what about this equation? We know that in argand plane, the equation mod of z minus z naught equal to r represents a circle, where z naught is the center of the circle and r is the radius. And this equation is very much similar to it. The only difference is that it is less than or equal to over here. Now less than or equal to actually represents, it is that region which is lying inside the circle and on the boundary of the circle as well. Fine. So here it is mod of z minus 3 less than or equal to 1, means the coordinates of the center of the circle are going to be 3, 0 and radius is 1. So that means I can say the region is x minus 3 whole square plus y square less than or equal to 1. Fine. Now students, let us plot this figure. So this is the circle whose center is 3, 0 and radius is 1. And this is the point 2, 0. Now we have the equation x minus y equal to 2. Let's see where this line intersects the given circle. So just substitute x equal to y plus 2 in the equation of the circle. So we will be getting y minus 1 whole square plus y square equal to 1. Ignore this less than or equal to sign. I am just solving the equation of the circle with the straight line. So we will be getting 2y square minus 2y equal to 0, or y is just 0 and 1. Now we move further. Now students, the values of y are 0 or 1, and we know that x is equal to y plus 2. So the corresponding values of x will be 2 or 3, right? So hence the points of intersection become 2, 0 and 3, 1. Now let us make the figure again. This point is 3, 0. This is 2, 0. And this point will be 3, 1. Now obviously the line joining 3, 0 and 3, 1 will be perpendicular to the x-axis. Let me call this point as P, this point as Q, and this point as R. So I can say the triangle PQR is right angled at the point R. Right? That means the minor arc PQ is making 90-degree angle at the center of the circle. So hence it is a quadrant. Fine. Now students, this chord PQ is dividing the circle into two parts. Let me call the area of the minor segment as alpha and the area of the major segment as beta. And we have to find the value of mod of alpha minus beta. Now to find the value of alpha, what should I do? I will be subtracting the area of triangle PQR from the area of the quadrant. Fine. So alpha becomes, the area of the quadrant is how much? It is 1/4 pi r square, and radius of the circle is 1. So it will be pi by 4 minus the area of the triangle PQR. Now this is 1. This is also 1. So the area of the triangle is half base into height, which is just 1 by 2. Fine. So this is the value of alpha. Now what is beta? Beta is the area of the circle minus alpha. Now area of circle is pi. So pi minus alpha. And this becomes pi minus pi by 4 minus half. So this becomes how much? 3 pi by 4 plus half. Now students, we have to calculate mod of alpha minus beta. So this is how much? This is just equal to pi by 2 plus 1. Fine. So this means the option D is the correct one. Now students, we move towards the next question. Now students, this question is based on the topic of binomial theorem. It says if summation r varying from 1 to 30 r square into 30 cr whole square divided upon 30 cr minus 1 equal to alpha into 2 to the power 29, then alpha is equal to. Now I will be solving this question by using three formulae. The first one is that NCR can be written as n upon r into n minus 1 CR minus 1. Secondly, we will be using NCR upon NCR minus 1 equal to n minus R plus 1 upon R. And thirdly, summation NCR R varying from 0 to n is equal to 2 to the power n. Right? Now students, just see how do I solve it. This is summation R varying from 1 to 30 R square. This 30 CR whole square can be splitted into 30 CR into 30 CR and divided upon 30 CR minus 1. Now this expression 30 CR upon 30 CR minus 1 we can simplify by using the second formula. And if you do not know this formula, just write the value of 30 CR and 30 CR minus 1 and divide both of them. Now this will become 31 minus R divided upon R into 30 CR. Now students, R and R are cancelled. Now we get R into 31 minus R. This 30 CR can now be written as 30 upon R into 29 CR minus 1. Now I have used the first formula. Fine. This R and this R get cancelled. Now 30 can be taken outside the summation. It becomes 30 times summation R varying from 1 to 30, 31 minus R into 29 CR minus 1. Right? Now students, we move further. Now students, this summation can now be splitted as 30 into 31 into summation R varying from 1 to 30, 29 CR minus 1 minus 30 into summation R varying from 1 to 30 R into 29 CR minus 1. Right? Now this becomes 930 summation R varying from 1 to 30, 29 CR minus 1 minus 30 into summation R varying from 1 to 30. Now students, this R I am writing as R minus 1 plus 1 into 29 CR minus 1. Fine. Now we know that summation R varying from 0 to n, NCR is equal to 2 to the power n. That means the third formula. So if you look carefully and expand this summation, what you are going to get? You will be getting 29C0 plus 29C1 plus 29C2 and so on till 29C29. So that means this can be written as 2 to the power 29. Fine. And this is minus 30 summation R varying from 1 to 30. Now I will rewrite this as R minus 1 into 29 CR minus 1. Now students, I am again using the first formula. 29 CR minus 1 I am writing as 29 upon R minus 1 into 28 CR minus 2. Right? And plus 29 CR minus 1. That means I have multiplied this R minus 1 with 29 CR minus 1 and then 1 with 29 CR minus 1. Fine. Now we will just split this summation into two parts. It becomes minus 30 times summation R varying from 1 to 30. Now students, this R minus 1 and R minus 1 just get cancelled. And this is 29 into 28 CR minus 2 minus 30 times summation R varying from 1 to 30, 29 CR minus 1. Fine. Now students, we move further. Now students, the expression becomes 930 into 2 to the power 29. And from the second summation, just take out 29 common. So now it becomes 29 into 30 into summation. Now when I put R equal to 1, the term becomes meaningless. So I will have to start from R equal to 2. So summation r varying from 2 to 30. Inside we have 28 cr minus 2 minus it is 30 times summation r varying from 1 to 30, 29 cr minus 1, right? Now it becomes 930 into 2 to the power 29 minus 870. Now students, what is the value of this summation? It is 28C0 plus 28C1 and so on till 28C28, which is nothing but 2 to the power 28. Just use the third formula minus 30 into. Now this summation becomes 2 to the power 29 because it is nothing but 29C0 plus 29C1 and so on till 29C29. Now students, just do the calculations. It becomes 900 into 2 to the power 29 minus, from this 870 just take out 1 2 and multiply it with 2 to the power 28. So it will become 435 into 2 to the power 29. Now when I take out 2 to the power 29 common inside the bracket, I am going to get 900 minus 435 and this becomes 465 into 2 to the power 29. Now students, this is alpha into 2 to the power 29. So we get the value of alpha as 465. Now students, we move towards the next question. Now students, this is really a tricky problem and based on one very important property of triangle. It says let A 6, 8, B 10 cos alpha, minus 10 sin alpha and C minus 10 sin alpha, 10 cos alpha be the vertices of a triangle if L a, 9 and G h, k be its orthocenter and its centroid respectively, then 5a minus 3h plus 6k plus 100 sin 2 alpha is equal to. That means we have to find the value of this particular expression. Now students, that important property which we have to use in this particular question is that in any non-equilateral triangle, centroid always divides the line joining orthocenter and circumcenter in the ratio 2:1 internally. That means if L is the orthocenter and G is the centroid and O is the circumcenter, then G divides LO in the ratio 2:1 internally. Now, since in this question, L a, 9 is the orthocenter and G h, k is the centroid, both points are different, they are distinct. So we are assuming that this triangle cannot be equilateral. But more specifically, if you want to know why this triangle cannot be equilateral, I will show this thing in the end of the question. Now, first of all, we will consider the case when the triangle is not equilateral. Fine. Then this is the situation. And now L is a, 9. G is given to us as h, k and the coordinates of circumcenter. Now students, look at these 3 points carefully. You can just observe and say that these 3 points are equidistant from the origin. Why? Because if you apply the distance formula and find the distance of all the 3 points from origin, that is 0, 0, the distance comes as 10. OA equal to OB equal to OC. And they are all 10. Fine. So that means origin will become the circumcenter of the triangle. Fine. That means all these 3 points will be located on the circle whose equation will be given by x square plus y square equal to 100. Fine. Now, O is 0, 0. Just apply section formula. What do you get? You will be getting 2 into 0, 0 plus 1 into A divided upon 3 equal to H. Similarly, you will be getting 2 into 0, 0 plus 1 into 9 divided upon 3 equal to K. So that means from here we get the value of K as 3. and we also get that A is equal to 3h. Fine. Now students, we find the coordinates of the centroid of the triangle by using the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, where x1, y1, x2, y2, x3 by 3 are the vertices of the triangle. So G becomes 6 plus 10 cos alpha minus 10 sin alpha, whole divided by 3, and comma, the y coordinate becomes 8 plus 10 times cos alpha minus sin alpha inside the bracket, whole divided upon 3, right? So this becomes the coordinates of the centroid. Now we move further. Now students, we have got the value of k as 3, and we have also got the y coordinate for the centroid G as 8 plus 10 times cos alpha minus sin alpha, whole divided upon 3. Now obviously both of these values must be equal to each other. So that means 8 plus 10 times cos alpha minus sin alpha should be equal to 9. So from here we get 10 times cos alpha minus sin alpha equal to 1. Now just square both sides of the equation. You will be getting 100 into cos square alpha plus sin square alpha minus 2 sin alpha cos alpha equal to 1. Now cos square alpha plus sin square alpha is just 1, and 2 sin alpha cos alpha is nothing but sin 2 alpha. So students, from here I get the value of 100 sin 2 alpha as 99. Right? Now we got the value of abscissa of the centroid as 6 plus 10 times cos alpha minus sin alpha, whole divided upon 3. This was h. Fine. And this is now 6 plus 1 divided upon 3. Why 6 plus 1? Because I have put the value of 10 cos alpha minus sin alpha, which we have just found. Fine. So that means the value of h is 7 upon 3. And we also had a equal to 3h. So a becomes nothing but 7. Now students, we have found the values of all the variables. So let's evaluate the expression finally. Expression was 5a minus 3h plus 6k plus 100 sin 2 alpha. Just put all the values. So 5a means 35, minus 3h means minus 7, 6k means 18, and 100 sin 2 alpha is 99. So the final answer becomes 145. Now students, I will explain you why this triangle cannot be equilateral. Now students, we know that for any triangle to be an equilateral triangle, all of its sides must be equal to each other. So we will be finding the values of AB square, BC square and CA square by using distance formula and check whether they are equal or not. Now the value of AB square will become 10 cos alpha minus 6 whole square plus minus 10 sin alpha minus 8 whole square. When you simplify it by opening up the brackets, you will be getting 200 minus 120 cos alpha plus 160 sin alpha. Right? Similarly, BC square is going to be 100 into cos alpha plus sin alpha whole square plus 100 into sin alpha plus cos alpha whole square. When you open up the brackets, you will be getting 200 plus 200 into sin 2 alpha. Now similarly, the value of CA square becomes 6 plus 10 sin alpha whole square plus 8 minus 10 cos alpha whole square. When you open up the brackets, you will be getting 200 plus 120 sin alpha minus 160 cos alpha. Now students, if all of them are equal, only then the triangle would be called as an equilateral triangle, otherwise not. Now let's put AB square equal to CA square and find the value of alpha. When you put both AB square and CA square equal to each other, you will be getting 40 cos alpha equal to 40 sin alpha. So that means cos alpha is equal to sin alpha. And if cos alpha is equal to sin alpha, it means tan alpha is equal to 1. Or alpha becomes equal to pi by 4. Now students, if alpha is equal to pi by 4, just put the value of alpha in all the sides, in the lengths of all the sides. What do you get? You will be getting. Now students, when you put the value of alpha equal to pi by 4 in all the lengths of the sides, then you get AB square equal to 200 plus 20 root 2. The value of BC square comes as 400 and CA square is again 200 plus 20 root 2. So this clearly means that all sides cannot be equal to each other. Hence, triangle ABC cannot be equilateral. So that means we have to consider the first case only, that is triangle is non-equilateral. Fine. Now we move to the next question. Now students, this question is based on the topic of three-dimensional geometry. It says, let L1 x minus 1 divided upon 2 equal to y minus 2 divided upon 3 equal to z minus 3 divided upon 4 and L2 x minus 2 divided upon 3 equal to y minus 4 divided upon 4 equal to z minus 5 divided upon 5 be two lines, then which of the following points lies on the line of the shortest distance between L1 and L2? Now students, basically in this question, first of all we have to find the equation of the line of the shortest distance, and then we will be checking among these 4 points which point satisfies that equation, right? Now we know that the line of the shortest distance is always perpendicular to the two given lines. So that means if I write the vector which is parallel to the first line, it is going to be b1 2i plus 3j plus 4k, and then I write the vector which is parallel to the second line, which is 3i plus 4j plus 5k, then I can say that direction ratios of the line of the shortest distance can be obtained from the vector d, which will be perpendicular to both b1 and b2, right? That means d will be nothing but b1 cross b2, right? Now let's find d vector first. It becomes ijk. In the second row we have 2 3 4, and in the third row we have 3 4 5. Now students, the vector d becomes equal to I into, now this value becomes minus 1 because it is 15 minus 16 minus j into, this becomes minus 2 plus k into, here it becomes minus 1. So that means the vector d comes as minus I plus 2j minus k. Now students, we move further. Now students, we have got the value of the vector d as minus I plus 2j minus k. So I can say that the direction ratios of the line of shortest distance are minus 1 is to 2 is to minus 1, right? Now there is another way of finding the direction ratios of the line of shortest distance. What is that way? We have the equation of line L1 as x minus 1 divided by 2 equal to y minus 2 divided by 3 equal to z minus 3 divided by 4. Put it equal to lambda and get the general coordinates of any point lying on this line. it becomes 2 lambda plus 1, comma 3 lambda plus 2, comma 4 lambda plus 3. Right? Now do the same thing for the line L2. Now the equation of L2 is x minus 2 divided by 3 equal to y minus 4 divided by 4 equal to z minus 5 divided by 5. Put it equal to mu, and from here get the general coordinates of any point lying on this line. It becomes 3 mu plus 2, comma 4 mu plus 4, comma 5 mu plus 5. Now students, let us suppose that the line of shortest distance intersects the line L1 at point P and the line L2 at point Q. Now, if I subtract the coordinates of the point P from the coordinates of point Q, or vice versa, then I will be getting the direction ratios of the line PQ. That means I will be getting the direction ratios of the line of shortest distance. Fine. And once we get the direction ratios in terms of lambda and mu, then we already have the direction ratios as numerical values. So we will be putting them proportional to each other to find equations in terms of lambda and mu. Now students, we move further. Now students, when we subtract the coordinates of point P from the coordinates of point Q, then we will be getting the direction ratios of the line of shortest distance. And these direction ratios come as 3 mu minus 2 lambda plus 1 is to 4 mu minus 3 lambda plus 2 is to 5 mu minus 4 lambda plus 2. Right? Now, they are proportional to the original direction ratios. Minus 1 is to 2 is to minus 1. So just create this proportion. Now, if we compare these two expressions, we will be getting an equation in terms of lambda and mu. Similarly, when we compare the last two expressions, we get another equation in terms of lambda and mu. We will solve both of these equations to get the values of lambda and mu, and hence we will find the coordinates of P and Q. Once we find the coordinates of P and Q, we can easily write the equation of the line of shortest distance. Right? Now students, let's do it. When we compare the first two expressions, we get the equation as 6 mu minus 4 lambda plus 2 equal to minus 4 mu plus 3 lambda minus 2. Or we get 10 mu minus 7 lambda equal to minus 4. So this is the equation number 1. Now let's compare the last two expressions. From here we get minus 4 mu plus 3 lambda minus 2 equal to 10 mu minus 8 lambda plus 4. Fine. Now from here the equation becomes 14 mu minus 11 lambda equal to minus 6. I am calling this as equation number 2. Now we will solve both the equations to get the values of lambda and mu. Now students, just multiply the equation number 1 by 11 throughout and multiply the equation number 2 by 7 throughout. So the first equation becomes 110 mu minus 77 lambda equal to minus 44, and the second equation becomes 98 mu minus 77 lambda equal to minus 42. Now just subtract the second equation from the first equation. You will be getting 12 mu equal to minus 2, or mu becomes minus 1 upon 6. Now when I put the value of mu in any of the original equations, I will be getting the value of lambda as 1 upon 3. Now students, it's very easy to find the coordinates of the point P, where the line of shortest distance is intersecting the line L1. Now how can I get the coordinates of point P? Just put the value of lambda in the general coordinates of the line L1. So the coordinates of P become 5 upon 3, comma 3, comma 13 upon 3. Now students, similarly, you can find the coordinates of the point Q, but there is no such requirement, because to write the equation of the line of shortest distance, we just need to get the coordinates of one point lying on this line. So the coordinates of P are sufficient. So the equation of line of shortest distance now becomes x minus 5 by 3 divided by minus 1 equal to y minus 3 divided by 2 equal to z minus 13 upon 3 divided by minus 1. Right? Now what you have to do, you have to consider all the options one by one and start putting the coordinates of the points given in them. Now when I take the first option, the point given is minus 5 by 3, comma minus 7, comma 1. Now when I put x as minus 5 by 3, the first value becomes 10 by 3. When I put the value of y as minus 7, the second value becomes minus 5. Obviously, these two values are not equal to each other. So hence this point is rejected. Now when I put the coordinates of the point given in the second option, that is option B, then in place of x, when I put 2, I get minus 1 upon 3 as the first value. And when I put y as 3, the second value becomes 0. Again, both of them are unequal, right? So this point is also rejected. Now we move to the third option. Here, when I put x as 14 upon 3, now the first value becomes 14 minus 5, which is 9. 9 divided by 3, which is 3. And 3 upon minus 1. This becomes the first value. When I put y as minus 3, the value becomes minus 6 divided by 2, which is again minus 3. And when I put the value of z as 22 by 3, it becomes 9 by 3, which is 3 divided upon minus 1. Now you can clearly see all of these values are equal to minus 3. So that means this particular point is lying on the line of shortest distance. So hence the option C is correct. Now students, we move towards the next question. Now students, this next question is based on the topic of ellipse. It says the length of the chord of the ellipse x square upon 4 plus y square upon 2 equal to 1, whose midpoint is 1 comma half is. Now we have to find the length of the chord of the ellipse whose midpoint is known to us. And we know that whenever the midpoint of the chord of the ellipse is given, then we can easily write the equation of that chord. And we know that the equation of the chord will be given by the equation t equal to s1. Now what is t here? T represents hx upon a square plus ky upon b square minus 1, where h comma k is the midpoint of the chord. And s1 refers to the value h square upon a square plus k square upon b square minus 1. Right? So this means the equation gets simplified to hx upon a square plus ky upon b square equal to h square upon a square plus k square upon b square. Now students, just put the values of h and k. H is 1 and k is half. So we will be getting x upon a square. What is a square here? It is 4. Plus 1 upon 2 into y divided upon b square, which is 2, equal to, this becomes 1 upon 4 plus this becomes 1 upon 8. Now this is x by 4 plus y upon 4 equal to 3 upon 8. Now if I multiply the whole equation with 4, I will be getting x plus y equal to 3 by 2. Right? Now students, we move further and find the length of the chord. Now students, let us say that the chord intersects the ellipse at two distinct points A and B, where A is x1, y1 and B is x2, y2. Now we have to calculate the length of the chord AB. So length AB will be given by square root of x1 minus x2 whole square plus y1 minus y2 whole square. Just apply distance formula. Now we know that both points A and B will satisfy the equation of the chord AB. So that means I can say x1 plus y1 equal to 3 by 2 further equal to x2 plus y2. So this means x1 plus y1 will be equal to x2 plus y2. Or I can say x1 minus x2 equal to y2 minus y1. We can also say that x1 minus x2 whole square will be equal to y1 minus y2 whole square. So this means this length AB can be written as root 2 into mod of y1 minus y2, because inside the square root it will become 2 times y1 minus y2 whole square. Now students, we have to just get the value of mod of y1 minus y2. And for this purpose, what we will be doing, we will solve the equation of the chord with the equation of the ellipse. Now, the equation of the ellipse was x square upon 4 plus y square upon 2 equal to 1. Now, this can be simplified to x square plus 2y square equal to 4. And the equation of the chord was x plus y equal to 3 by 2. So just put the value of x from the equation of the chord in terms of y into the equation of ellipse. So you will be getting 3 by 2 minus y whole square plus 2y square equal to 4. Now just simplify this equation. You will be getting 3y square minus 3y plus 9 by 4 minus 4 equal to 0. So this becomes 3y square minus 3y, and this is minus 7 by 4 equal to 0. Fine. Now students, we move further. Now students, the equation becomes 12y square minus 12y minus 7 equal to 0. Now obviously y1 and y2 will be the roots of this equation. Why? Because we have mutually solved the equation of the chord with the equation of the ellipse to get the points of intersection. And since the equation which we have got is in terms of y, so the roots of this equation will clearly give us the ordinates of the points of intersection of the chord with the ellipse. Right? Now mod of y1 minus y2 can be written as square root of y1 plus y2 whole square minus 4y1 y2. Basically, it represents the absolute difference of the roots. Now students, just put in the value of the sum of roots and product of roots and you will get the value. So this is square root of 1 minus 4 times minus 7 upon 12. And this becomes square root of 1 plus 7 upon 3, which becomes square root of 10 upon 3. Right? Now students, the value of AB was root 2 into mod of y1 minus y2. So this becomes root 2 into root 10 divided upon root 3. When we simplify this, it becomes 2 root 5 divided upon root 3. If you rationalize it, you will be getting 2 root 15 divided upon 3. Now students, option C is the correct one. Now we move to the next question. Now students, this next question is based on the topic of quadratic equations. It says the product of all the rational roots of the equation x square minus 9x plus 11 whole square minus inside the bracket x minus 4 into inside the bracket x minus 5 equal to 3 is equal to. Now clearly, if I just simplify this equation by multiplying the terms in the second bracket, that is x minus 4 into x minus 5, I will be getting x square minus 9x plus 20 inside the bracket. Now students, we are clearly noticing a pattern that x square minus 9x is common in both of these terms. So what I do, I put x square minus 9x plus 11 as y. If I put this value as y, the equation becomes y square minus, inside the bracket now it will become y plus 9, because 20 can be splitted into 11 plus 9 and further equal to 3. Now we have got the equation as y square minus y minus 12 equal to 0. This can easily be solved, and this is y minus 4 into y plus 3 equal to 0. Or we get two values of y and they are 4 or minus 3. Now y was x square minus 9x plus 11. So just put this value equal to 4 to get the roots. X square minus 9x plus 7 is equal to 0. Now students, clearly the discriminant of this equation is going to be a non-perfect square quantity, because it will come as 81 minus 28, and which is 53. Fine. So obviously the roots of this particular equation are going to be irrational numbers or irrational roots. So we will be just avoiding them. And now we move to the second case. Now students, in the second case, we have the value of y equal to minus 3, which means x square minus 9x plus 11 is equal to minus 3. Or we get the equation as x square minus 9x plus 14 equal to 0. When we factorize it, we get x minus 7 into x minus 2 equal to 0. And from here we get two rational roots, and they are 7 and 2. Their product is 14. So that means the option D is the correct one. Now we move towards the next question. Now students, this is really a challenging problem on complex numbers. It says if alpha and beta are the roots of the equation 2x square minus 3x minus 2 iota equal to 0, where iota is equal to square root of minus 1, then we have to evaluate the expression 16 into real part of alpha to the power 19 plus beta to the power 19 plus alpha to the power 11 plus beta to the power 11 whole divided upon alpha to the power 15 plus beta to the power 15 into imaginary part of alpha to the power 19 plus beta to the power 19 plus alpha to the power 11 plus beta to the power 11 whole divided upon alpha to the power 15 plus beta to the power 15. Now basically in this question we have to find the value of this particular expression inside the bracket, and then we will be finding its real and imaginary parts and then finding their product. Now most often students will try to find the roots of this equation, and this is a common mistake. Do not find the roots of this equation. You have to follow a different process. Just see how do I do this. Now since alpha and beta are the roots of this equation, so they must satisfy this equation. So I can write 2 alpha square minus 3 alpha minus 2 iota equal to 0. That means I can say 2 times alpha square minus iota equal to 3 alpha. Right? Now if I divide both sides of the equation by 2 alpha, I will be getting alpha minus iota by alpha equal to 3 by 2. Right? Now students, just square both sides of this equation. You will be getting alpha square plus iota square upon alpha square, which means minus 1 upon alpha square, and then minus 2 iota equal to 9 upon 4. Now just take 2 iota onto the other side. You will be getting alpha square upon 1 minus alpha square equal to 9 upon 4 plus 2 iota. Fine. Now students, again square both sides of this equation. So now you will be getting alpha to the power 4 plus 1 upon alpha to the power 4 minus 2 equal to 81 upon 16 plus 4 iota square, which is nothing but minus 4 plus 9 iota, right? So from here I can say alpha to the power 4 plus 1 upon alpha to the power 4 is equal to 81 upon 16 minus 2 plus 9 iota. And this gets simplified to 49 upon 16 plus 9 iota. Now students, we move further. Now students, the expression inside the bracket is alpha to the power 19 plus beta to the power 19 plus alpha to the power 11 plus beta to the power 11 whole divided upon alpha to the power 15 plus beta to the power 15. Fine. This can further be written as alpha to the power 15 common inside the bracket alpha to the power 4 plus 1 upon alpha to the power 4 plus beta to the power 15 common and inside the bracket beta to the power 4 plus 1 upon beta to the power 4 whole divided upon alpha to the power 15 plus beta to the power 15. Now students, we have just got the value of alpha to the power 4 plus 1 upon alpha to the power 4 as 49 upon 16 plus 9 iota. Now since alpha and beta both are the roots of the original equation, so doing the same process for beta, you will be getting the value of beta to the power 4 plus 1 upon beta to the power 4 same as 49 upon 16 plus 9 iota. Now just put these two values over here. So the value of the expression becomes 49 upon 16 plus 9 iota common into alpha to the power 15 plus beta to the power 15 whole divided upon alpha to the power 15 plus beta to the power 15. Now students, this expression gets cancelled and the value becomes 49 upon 16 plus 9 iota. Now we have to evaluate the expression 16 into real part of this complex number into its imaginary part. So it becomes 16 into 49 upon 16 into 9. So this finally comes as 441. So that means option A is the correct one. Now students, we move towards the next question. Now students, it is an interesting problem on the topic of functions. It is somewhat similar to the question that was asked in JEE Advanced 2020. I have made a video on that particular question. You can go to my playlist JEE Main and Advanced previous year questions and you will find its video over there. If you had practiced that particular question earlier, then there is very strong chance that you will be able to solve this question. Now let's move towards its solution. It says let fx equal to 2 to the power x plus 2 plus 16 whole divided upon 2 to the power 2x plus 1 plus 2 to the power x plus 4 plus 32. Then the value of 8 times inside the bracket f of 1 upon 15 plus f of 2 upon 15 plus f of 3 upon 15 and so on till f of 59 upon 15 is equal to. Now students, in order to simplify this fx, what I do, I put t equal to 2 power x. So now the expression for fx becomes equal to 4t plus 16. Why 4t? Because I have split it 2 power x plus 2 as 2 power x into 2 power 2. And in the denominator, I will be getting 2t square plus 16t plus 32, right? Now take out 4 common from the numerator and in the denominator just take out 2 common. inside the bracket you will be getting t square plus 8t plus 60. Now in the denominator it is nothing but 2 times t plus 4 whole square, and in the numerator it was 4 times t plus 4. So t plus 4 will cancel out and 2 will also cancel out, and we will be getting 2 upon t plus 4. So just put the value of t equal to 2 power x again. So the value of fx becomes equal to 2 divided upon 2 power x plus 4. Fine. Now this is the simplest form of fx. Now we move further. Now students, it is the most important part of the question. Now what you have to do, you have to find the value of f of 4 minus x. So in the function fx, just replace x by 4 minus x. So the value of f of 4 minus x will become equal to 2 divided upon 2 to the power 4 minus x plus 4. This can be written as 2 divided upon 16 divided upon 2 power x plus 4, which can further be written as 2 into 2 power x whole divided upon 16 plus 4 into 2 power x. Just cancel out 2 from numerator and denominator. You will be getting 2 power x divided upon 2 into 2 power x plus 8. So take out 2 common from the denominator. Inside the bracket, you will be having 2 power x plus 4. Right? Now this is the value of f of 4 minus x. And we had the value of fx as 2 upon 2 power x plus 4. Now students, this 2 upon 2 power x plus 4 can be written as 4 upon 2 times 2 to the power x plus 4. Why I'm doing this? Because my intention is to add f of x and f of 4 minus x, because it will help me to add both of these functions. Now when I add, what do I get? The denominator is same. So denominator becomes 2 times 2 to the power x plus 4, and in the numerator I am having 2 to the power x plus 4. And this finally becomes half, because 2 to the power x plus 4 cancel out from the numerator and denominator. So that means now we have found very important property of this function, and that is f of x plus f of 4 minus x will be equal to half, and it is independent of the value of x. That means it can be any x, any real x, but the value of f of x plus f of 4 minus x will always be equal to half. Now we will be using this property and find the value of the expression. Now students, we have to find the value of the expression 8 times inside the bracket f of 1 upon 15 plus f of 2 upon 15 plus f of 3 upon 15 and so on till f of 59 upon 15. Now inside the bracket we are having 59 terms. Now what you have to do, you have to select the pairs of those terms, the sum of whose inputs is equal to 4, like f of 1 upon 15 and f of 59 upon 15. Why I'm saying so? Because we have just proved that f of x plus f of 4 minus x is equal to half. That means whenever the sum of the inputs of this function is 4, then the sum of their corresponding outputs will be equal to half. So similarly, you can choose another pair as f of 2 upon 15 and f of 58 upon 15. Similarly, f of 3 upon 15 and f of 57 upon 15. Fine. The sum of all these pairs is going to be half. Now, how many such pairs can be formed? Now, there are 59 terms. So obviously, we can form 29 such pairs. And the middlemost term will be left alone. So how to find the middlemost term? There are 59 terms. So 59 plus 1 divided upon 2. So that means the 30th term, or f of 30 upon 15, would be left alone. So this is nothing but f of 2. So the value of the expression can be written as 8 times inside the bracket. It is 29 upon 2 plus f of 2, right? Now students, this becomes how much? 4 into 29 plus 8 times f of 2. And what was f of x? F of x was 2 divided upon 2 power x plus 4. So this becomes, f of 2 becomes 2 divided upon 4 plus 4. That means the value of the expression becomes 4 into 29 plus 2, because this 8 and 8 will cancel out. And finally, the value becomes 180. So that means option A is the correct one. Now students, we move to the next question. Now students, this is really a challenging problem on complex numbers. It says let alpha comma beta be the roots of the equation x square minus ax minus b equal to 0 with imaginary part of alpha less than imaginary part of beta. Let Pn equal to alpha power n minus beta power n if P3 equal to minus 5 into root 7 into iota, P4 equal to minus 3 into root 7 into iota, P5 equal to 11 into root 7 into iota, and P6 is equal to 45 into root 7 into iota, then we have to find the value of mod of alpha power 4 plus beta power 4. Now students, in order to get the value of mod of alpha power 4 plus beta power 4, first of all, you need to get the values of a and b. And in order to get the values of a and b, you need to utilize these given expressions. So first of all, I will be starting with P5. Now what is going to be P5? It is alpha power 5 minus beta power 5. Just put n equal to 5 in this. You will be getting P5 as alpha power 5 minus beta power 5. Now multiply this term with alpha plus beta and see what happens. When you multiply these two terms, you will be getting alpha power 6 plus alpha power 5 into beta minus beta power 5 into alpha minus beta power 6. So that means P5 into, what is alpha plus beta? It is just a, equal to alpha power 6 minus beta power 6 can be written as P6. And from the remaining two terms, take out alpha beta common. Inside the bracket, you will be getting alpha power 4 minus beta power 4. So this can further be written as P6 plus. Now what is alpha beta? It is minus B. And what is alpha power 4 minus beta power 4? It is P4, right? So we will be getting the equation A into P5 plus B into P4 equal to P6. Now students, we have the values of P4, P5 and P6. Just put these values in this equation and you will be getting an equation in terms of A and B. So when you put the values of P4, P5 and P6, what do you get? You will be getting A into 11 into root 7 iota plus B into, what is P4? It is minus 3 into root 7 iota equal to P6, and P6 is 45 into root 7 iota. Now root 7 iota gets cancelled throughout. So I will be getting 11A minus 3B equal to 45. Now students, this is our first equation. Now similarly, we will find another equation in terms of A and B, and then we will solve both the equations to get the values of A and B. Now students, we will multiply alpha power 4 minus beta power 4 with alpha plus beta. When you multiply these two terms, what do you get? You will be getting alpha power 5 plus alpha power 4 into beta minus beta power 4 into alpha minus beta power 5. Now alpha power 4 minus beta power 4 is P4 and alpha plus beta is A. So A into P4 becomes equal to, what is alpha power 5 minus beta power 5? It is P5. And from the remaining two terms, take out alpha beta common inside the bracket. You will be getting alpha cube minus beta cube. Now A into P4 is equal to P5 minus B into P3, right? So that means I can write A into P4 plus B into P3 equal to P5. Now students, just put in the values of P3, P4 and P5 to get another equation in terms of A and B. So now it becomes minus 3 into root 7 iota into A plus minus 5 into root 7 iota into B equal to 11 into root 7 iota. Now students, root 7 iota will get cancelled throughout and we will be getting minus 3a minus 5b equal to 11. Or we get 3a plus 5b equal to minus 11. So this is our second equation. Now just solve both the equations by using the method of coefficient elimination. So the first equation was 11a minus 3b equal to 45, and this is the second equation, 3a plus 5b equal to minus 11. Multiply the first equation by 5 and multiply the second equation by 3 and add both of them. So when you add both of them, you will be getting 64a equal to 192, or a becomes equal to 3. Now students, when a is equal to 3, just put it in any of these equations. Let's put this value of a in the second equation. So we get 9 plus 5b equal to minus 11, or 5b becomes equal to minus 20, or b becomes equal to minus 4, right? Now b is equal to minus 4 and a is equal to 3. Now we will be using both of the values to find the value of mod of alpha power 4 plus beta power 4. Now students, we know that alpha plus beta whole square can be written as alpha square plus beta square plus 2 alpha beta, right? Now what is alpha plus beta? It is a, so this becomes a square equal to alpha square plus beta square. What is alpha beta? It is minus b, so this is minus 2b. So from here we get the value of alpha square plus beta square as a square plus 2b. And we have just found the values of a and b. So put these values over here. The value of alpha square plus beta square becomes 9 minus 8, which is equal to 1. Now students, square both sides of this equation to get the value of alpha power 4 plus beta power 4. So now I can write alpha power 4 plus beta power 4 plus 2 alpha square into beta square equal to 1. That means alpha power 4 plus beta power 4 is equal to 1 minus 2 into alpha square beta square, and this is 2 into minus b square. So this is 1 minus 2b square, and the value of b square is 16. So this becomes 1 minus 32 or minus 31. So what should be the value of mod of alpha power 4 plus beta power 4? It should be equal to 31. So 31 is the correct answer. Now students, we move towards the next question. Now students, this question is based on the topic of straight lines. It says, let the lines 3x minus 4y minus alpha equal to 0, comma 8x minus 11y minus 33 equal to 0, and 2x minus 3y plus lambda equal to 0 be concurrent if the image of the point 1, 2 in the line 2x minus 3y plus lambda equal to 0 is 57 upon 13, comma minus 40 upon 13, then mod of alpha into lambda is equal to. Now we can use a direct formula in this particular question, and that is if three straight lines whose equations are given by a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 equal to 0. If these three straight lines are concurrent, that means they intersect in the same point, then the value of this determinant of a1 b1 c1, a2 b2 c2 and a3 b3 c3 will always be equal to 0. Students, just put in the values of A1, B1, C1, A2, B2, C2, A3, B3, C3 in this determinant, and now you will be getting a linear equation in terms of alpha and lambda. So here I will be having 3 minus 4 and minus alpha. In the second row it is 8 minus 11 minus 33. In the third row it is 2 minus 3 and lambda. Now let's solve this determinant and get the equation. Now students, let us expand the determinant along the first row. So we will be getting 3 times inside the bracket minus 11 lambda minus 99 plus 4 times inside the bracket it is 8 lambda plus 66 minus alpha into inside the bracket it is minus 24 plus 22 equal to 0. So when we do the calculations, it becomes minus 33 lambda minus 297 plus 32 lambda plus 264 plus 2 alpha equal to 0. And finally, we get the equation as 2 alpha minus lambda equal to 33. So this is our equation number 1, right? Now students, we have been given that the coordinates of the image of the point 1, 2, I am calling this point as P, in the line 2x minus 3y plus lambda equal to 0 is 57 upon 13 comma minus 40 upon 13. Let me call this point as the point Q. So it's very much obvious that the point P and Q will be equidistant from the given line. So hence I can say the midpoint of PQ, which is M, I am calling this by the name M, will lie on the line 2x minus 3y plus lambda equal to 0. Fine. That means the coordinates of M will satisfy the equation of the line. So let us calculate the coordinates of M. It becomes 57 upon 13 plus 1 divided upon 2. So this is how much? This is 35 upon 13, comma, minus 40 upon 13 plus 2 whole divided upon 2. So this becomes how much? It is minus 7 upon 13. Now these coordinates will satisfy the equation of the line. Just put these coordinates in the equation of the line. So it becomes 70 upon 13 plus 21 upon 13 plus lambda equal to 0. So students, from here we get the value of the lambda as minus 91 upon 13 or lambda equal to minus 7. Now we move further. Now students, just put the value of lambda obtained in the equation 2 alpha minus lambda equal to 33. So 2 alpha plus 7 becomes equal to 33 or 2 alpha is equal to 26. So from here we get alpha equal to 13. So now the value of mod of alpha into lambda becomes mod of minus 91, and this is nothing but 91. So hence option D is the correct one. Now students, we move towards the next question. Now students, this question is based on the topic of inverse trigonometry. It says if alpha greater than beta greater than gamma greater than 0, then the expression cot inverse of beta plus 1 plus beta square divided upon alpha minus beta plus cot inverse of gamma plus 1 plus gamma square divided upon beta minus gamma plus cot inverse of alpha plus 1 plus alpha square divided upon gamma minus alpha is equal to. Now let's start with the first term. This is cot inverse of, inside the bracket, just take the LCM of the denominators. It is alpha minus beta. In the numerator, it will become alpha beta minus beta square plus 1 plus beta square. Now this becomes cot inverse of 1 plus alpha beta divided upon alpha minus beta. Now students, we know that tan inverse 1 upon x is equal to cot inverse x whenever x is positive, right? So that means with the help of this formula, I can write cot inverse 1 plus alpha beta divided upon alpha minus beta as tan inverse of alpha minus beta divided upon 1 plus alpha beta. Because I also know that alpha is greater than beta and both of these quantities are positive. So that means input inside the function cot inverse is positive. Now by the formula tan inverse x minus y divided upon 1 plus xy equal to tan inverse x minus tan inverse y, this can further be written as tan inverse alpha minus tan inverse beta. Fine. Now similarly, we can simplify the second term. That will become cot inverse of beta gamma minus gamma square plus 1 plus gamma square divided upon beta minus gamma. This will become cot inverse of 1 plus beta gamma divided upon beta minus gamma. Now students, both beta and gamma are positive quantities and beta is greater than gamma. So that means again cot inverse of 1 plus beta gamma divided upon beta minus gamma can be written as tan inverse of beta minus gamma divided upon 1 plus beta gamma. So that means this further can be written as tan inverse beta minus tan inverse gamma. Now these are the first two terms. Now we move to the last term. Now students, last term will become cot inverse of alpha gamma minus alpha square plus 1 plus alpha square divided upon gamma minus alpha. Right? Now alpha square and minus alpha square will cancel out and this will become cot inverse of 1 plus alpha gamma divided upon gamma minus alpha. Now students, here is the difference. Because the term in the denominator is negative. We were given that alpha greater than beta greater than gamma. That means alpha is greater than gamma. So obviously gamma minus alpha will be a negative quantity. Whereas both alpha and gamma are positive. So that means numerator is positive. So now here we will use this rule that tan inverse 1 upon x is equal to minus pi plus cot inverse x if x is negative. So that means cot inverse x will be equal to pi plus tan inverse 1 by x. So this expression will become pi plus tan inverse of gamma minus alpha divided upon 1 plus alpha gamma. And this can further be written as pi plus tan inverse gamma minus tan inverse alpha. Now students, just add all the terms. Finally, you will be getting pi as the answer, right? So that means option D is the correct one. Now we move to the next question. Now students, this question is based on the topic of permutations and combinations. It says, if all the words with or without meaning made using all the letters of the word Kanpur are arranged as in a dictionary, then the word at the 440th position in this arrangement is. Now, if we have to form the words as per the dictionary, then the first word which we can form by using the letters of the word Kanpur is going to be A, then K, then N, then P, then R, and then U. Now students, if I keep A fixed at first place and permute all other letters, then the total number of words which I can form is factorial 5 or 120 words. Now after the list of all the words starting with A is over, I will be writing the words starting with K. So again 120 words. After this, we will write the words starting with N. Again factorial 5 or 120 words. So till now we have written 360 words. Now do not jump to say that now we'll be writing all the words starting with P, because it will add up to 480. 360 plus 120 and 480 is more than 440. So this clearly means that the required word is going to fall in the list of the words which are going to start with P. So here you have to move slowly and be careful. Now this is the first word which is going to be starting with P, and this is PAK, then N, then R, and then U. Now students, this time I will be keeping P fixed at first place and A fixed at second place. And now I will permute the last four letters. So I will be getting factorial 4 such words, that is 24 words. Then in place of A, I will have now K. And again, last four letters we have to permute. 24 such words, fine. After PK, now we will write the words starting with P, and the second letter of the words is going to be N. Again, last four letters you have to permute. So till now you have written 360 plus 72. This adds up to 432. Now students, after this again you have to be careful. Now we move further. Now students, we will be writing the words starting with P and their second letter as R. But this time do remember, we do not have to write all such words. This is the 433rd word I am going to write. It is going to be P, R, A, K, N, and then U. Now to get the words starting with P, R, and A, that means first three letters fixed, I will be permuting the last three letters. So this is how we will get 6 more words. And till now we have written 438 such words. Fine. Now students, this is the 439th word. It is going to be P, R. Now we will be replacing A by K. So it is going to be P and then R, then K, then A, then N, and then U. Now students, to get the 440th word, just do the permutation of the last two letters. It is going to be P, R, K, A, U, and then N. So this is the final answer, and hence option C is correct. Now students, we move to the next question. Now students, it is a nice question on trigonometry. It says if sin x plus sin square x equal to 1, where x belongs to open interval 0 to pi by 2, then we have to find the value of the expression cos x power 12 plus tan x power 12 plus 3 times inside the bracket cos x power 10 plus tan x power 10 plus cos x power 8 plus tan x power 8 bracket close plus cos x power 6 plus tan x power 6. Right? Now it seems to be a big expression, but we can simplify it by converting all the trigonometric ratios in terms of sin x. Now just see how do I do this. Sin x plus sin square x is given equal to 1. So that means sin x can be put equal to 1 minus sin square x. And we know that by identity cos square x plus sin square x equal to 1, we can write 1 minus sin square x as cos square x. And we can also write sin x upon cos x equal to cos x. That means tan x will be equal to cos x. I have just divided the equation sin x equal to cos square x by cos x throughout, because x lies in open interval 0 to pi by 2. So that means cos x cannot be equal to 0, right? Now, what will be the benefit of doing this? Wherever in this expression cos square x is coming, you will just substitute it as sin x. And wherever tan x is coming, you can replace it by cos x. Fine. Now students, the first term is cos x power 12. cos x power 12 can be written as cos square x whole power 6, and cos square x is sin x. So this just becomes sin x power 6. Next term is tan x power 12. Tan x is nothing but cos x, and tan x power 12 will become cos x power 12, which is again same as the first term. That means sin x power 6, right? Then we have 3 times inside the bracket. It is cos x power 10. Cos x power 10 can be written as cos square x whole power 5. Now cos square x is sin x. So this becomes sin x power 5. Tan x power 10 again becomes same as cos x power 10, and cos x power 10 is same as sin x power 5. Then we have cos x power 8. That will become cos square x whole power 4. That means it is sin x whole power 4. Similarly, tan x power 8 is same as cos x power 8, which means this is same as sin x power 4. Now bracket close, and the remaining last two terms can be written as cos x power 6 can be written as cos square x whole power 3. So it becomes sin cube x. And similarly, tan x power 6 is same as cos x power 6, which can again be written as sin cube x. Now students, just collect all the terms. 2 will come common. Inside the bracket, I will be getting sin x power 6 plus 3 times sin x power 5 plus sin x power 4, and in the last I'm having sin cube x, right? Now we move further. Now students, this expression can further be written as 2 times inside the bracket sin x power 6 plus sin cube x plus 3 times I am taking out sin cube x common from the bracket containing the terms sin x power 4 plus sin x power 5. This is important step. Look carefully. I am taking out sin cube x common. Now inside the bracket, I will be having sin x plus sin square x, right? Now students, this expression has taken the shape of an identity. Just see which identity is this. This sin x power 6 can be written as sin square x whole cube. This sin cube x is nothing but cube of sin x. This sin cube x can be written as sin square x into sin x. And inside the bracket, we are already having sin x plus sin square x. So now it has taken the shape of a cube plus b cube plus 3ab into a plus b, and which is nothing but a plus b whole cube. So the expression becomes 2 times inside the bracket sin x plus sin square x, and it is the cube of this quantity. That is 2 times sin x plus sin square x whole cube. So we know that sin x plus sin square x is just 1. So the answer is just 2. So students, option A is the correct one. Now we move towards the next question. Now students, this question is based on the topic of definite integrals. It's a nice question. We have to evaluate 80 times the integral 0 to pi by 4 sin theta plus cos theta d theta divided upon 9 plus 16 into sin 2 theta. Now we know that sin theta minus cos theta whole square can be written as sin square theta plus cos square theta minus 2 sin theta into cos theta. And sin square theta plus cos square theta is nothing but 1. And 2 sin theta cos theta can be written as sin 2 theta. So that means we have an expression for sin 2 theta as 1 minus sin theta minus cos theta whole square. So that means in this particular integral, I will replace sin 2 theta by 1 minus sin theta minus cos theta whole square. Fine. Now just see, the integral becomes 80 times 0 to pi by 4. In the numerator, we have sin theta plus cos theta. And in the denominator, it becomes 9 plus 16 times 1 minus sine theta minus cos theta whole square. Right? Now students, what you have to do? You have to do substitution. Just substitute sine theta minus cos theta as t. So now when you differentiate both sides with respect to theta, you will be getting cos theta plus sine theta d theta equal to dt. Right? So this means the integral becomes 80 times. Now the limits will also change. When theta is equal to 0, then t will be equal to -1. And when theta is equal to pi by 4, then t will be equal to 0. And in the numerator, sine theta plus cos theta d theta will be just replaced by dt. In the denominator, we will be having 9 plus 16 times 1 minus t square. Right? Now students, we move further. Now students, the integral becomes 80 times -1 to 0 dt upon 9 plus 16, which is 25, minus 16t square. Now just take out 16 common from the denominator. Outside the integral, it becomes 80 upon 16, which is 5 into integral -1 to 0 dt upon 25 upon 16 can be written as 5 upon 4 whole square minus t square. Now it has taken the shape of a direct formula, and that is integral dx upon a square minus x square. So just apply the formula. It becomes 5 into 1 upon 2a, means 1 upon 2 into 5 upon 4 into log mod a plus x upon a minus x. Now here it is going to be 5 upon 4 plus t upon 5 by 4 minus t. Right? And the limits are from -1 to 0. Fine. Now students, just do the calculations. So it becomes 2 times log mod 5 by 4 plus 0 upon 5 by 4 minus 0. So this is nothing but log 1 minus log of mod of 5 by 4 minus 1, which becomes 1 upon 4 divided upon 5 by 4 plus 1, which is 9 by 4. Now students, we know that log 1 is nothing but 0, and here it becomes log 1 by 9. So just do the calculations. Log 1 upon 9 is nothing but minus log 9. So this becomes finally 2 log 9. Or this can further be written as, because log 9 is nothing but log of 3 square. So this can be written as 2 into 2 into log 3, or 4 log 3. Now students, option A is the correct one. Now we move towards the next question. Now students, this question is based on the topic of determinants. It also involves some concepts of trigonometry. It says, let capital M and small m respectively be the maximum and the minimum values of fx equal to, given by this determinant, where x belongs to capital R, then m to the power 4 minus small m to the power 4 is equal to. Now students, first of all, we will expand this determinant by using properties. Now fx is equal to determinant of 1 plus sine square x, then cos square x, then 4 sine 4x, and this is sine square x, sine square x. This is 1 plus cos square x. Here it is cos square x. This is 4 sine 4x. And this is 1 plus 4 sine 4x. Right? Now students, you can clearly observe, if I do these operations, R1 tending to R1 minus R2 and R2 tending to R2 minus R3, both of them simultaneously, then I will be getting fx equal to determinant. In the first row, I am going to get just 1. then 0, and then minus 1, right? In the second row, I will be getting 0, then 1, and then minus 1. And in the third row, the terms are just as before, sin square x, cos square x, and 1 plus 4 sin 4x. Right? Now, students, we move further and expand this determinant. Now, students, we will expand the determinant along the first row. So f of x becomes equal to 1 into, inside the bracket, 1 plus 4 sin 4x plus cos square x. Then outside the bracket, it becomes 0, and then minus 1 into minus sin square x. Right? Now we will add all the terms. We know that cos square x plus sin square x, it is 1. So the value of fx becomes equal to 2 plus 4 sin 4x. Now, students, to find the maximum and minimum values of this function fx, we know that sin theta always lies between minus 1 to 1. So that means sin 4x will also lie between minus 1 to 1. So 4 times sin 4x will lie between minus 4 to 4. And if I add 2 throughout the inequality, then 2 plus 4 sin 4x will lie between minus 2 to 6. So that means the value of capital M, which is the maximum value of fx, it is 6, and the value of small m, that is the minimum value of fx, it is minus 2. And we have to calculate m to the power 4 minus small m to the power 4. So this is 1296 minus 16, and this is 1280. So that means option D is correct one. Now, students, we move towards the next question. Now, students, this question is based on the topic of sequences and series. It says, let A1, A2, A3 and so on up to A 2024 be an arithmetic progression such that A1 plus inside the bracket A5 plus A10 plus A15 and so on up to A 2020 bracket close plus A 2024 equal to 2233. Then A1 plus A2 plus A3 and so on up to A 2024 is equal to. Now, it's very much obvious that in this question, we have to find the sum of first 2024 terms of the AP. Now, students, if you look carefully inside the terms of the bracket of this sum, then the suffixes of all these terms are consecutive multiples of 5. Why? Because they are 5, 10, 15 and so on up to 2020. So if I tell you to find the total number of terms present inside the bracket, then the answer is very much clear. It is 2020 divided upon 5. So that means there are 404 terms present inside the bracket. Right? Now let me rewrite this sum. It is A1 plus inside the bracket A5 plus A10 plus A15, and the last term which is given to us inside the bracket, it is A 2020. Outside the bracket, it is A 2024. Now just before A 2020, we will be having A 2015, and before A 2015, we will be having A 2010. Now you have to notice one very important pattern that is being formed in this sum, and that is A1 and A 2024, they are first and last terms of the AP. A5 and A 2020, they are the fifth terms from beginning and end of the AP. A10 and A 2015, they are 10th terms from beginning and end of the AP. A15 and A 2010, they are 15th terms from beginning and end of the AP. So that means in this particular sum, we are going to have such pairs in which there is sum of equidistant terms from beginning and end of the AP. Fine. Now, how many such pairs are there? Since there were 404 terms present inside the bracket and 2 terms were outside the bracket inside the sum. So that means in all we are having 406 terms. So obviously 406 divided by 2, that means 203 such pairs. Now we have to use one very important property of AP, and that is the sum of the terms equidistant from beginning and end in an AP is equal to the sum of first and last term. That means each pair is going to be equal to, the sum of each pair is going to be equal to A1 plus A 2024, right? And how many such pairs are there? It is 203. So that means we will be having 203 into A1 plus A 2024 as the sum of this expression, which is further given to us equal to 2233. So that means from here, what do I get? I will be getting A1 plus A 2024 as 2233 divided upon 203. And this is nothing but 11. Fine. Now students, we will find the sum of first 2024 terms and just apply the formula. It becomes 2024 divided upon 2 into A1 plus A 2024. And this is nothing but 1012 into 11. So the final answer comes as 11132. So it was a nice question. Now students, we move towards the next question. Now students, it's an interesting question involving the concepts of functions and maxima and minima. It says, let f closed 0 to 3 to capital A be defined by f of x equal to 2 into x cube minus 15 into x square plus 36x plus 7, and g closed 0 to infinity to capital B be defined by g of x equal to x to the power 2025 divided upon x to the power 2025 plus 1 if both the functions are onto and S is equal to the set containing x belonging to capital Z such that x belongs to capital A or x belongs to capital B, then n of S is equal to. That means we have to find the total number of elements present in the set S. Now students, I will be starting with the function fx. Fx is equal to 2 into x cube minus 15 into x square plus 36x plus 7. So just differentiate this function with respect to x. You will be getting 6x square minus 30x plus 36. Take out 6 common. Inside the bracket, you will be getting x square minus 5x plus 6. Now this can further be written as 6 times x minus 2 into x minus 3. Now students, if I put f dash x equal to 0, I will be getting 2 stationary points. And they are either x equal to 2 or x equal to 3. Now to decide at which point we are going to get maxima and at which point we are going to get minima, we will use second derivative test. So just differentiate again. F double dash x becomes equal to 6 times 2x minus 5. Now when I put x as 2 in this, then the value is negative, clearly indicating that at x equal to 2 we are going to get local maxima. Fine. Now we move further. Now students, let's find the value of f double dash 3. The value of f double dash 3 comes as 6, which is a positive quantity. So it means the function attains local minima at x equal to 3. Now we can easily conclude that in the interval closed 0 to 2 open, fx is increasing. At x equal to 2, it attains local maxima, and in the open interval 2 to 3, fx is decreasing. At x equal to 3, it attains local minima. Fine. Now students, if I find the value of f of 0, it is 7. the value of f of 2, it is 35, and the value of f of 3, it is 34. So if we plot the rough graph of fx, then it is going to be like this, where it attains the maximum value equal to 35 at x equal to 2, and then it comes down to 34 at x equal to 3. And it starts from 7. So from here I can clearly say the range of fx is going to be closed 7 to 35. Now since fx is a polynomial function, obviously it is going to be continuous also. This is why we can directly plot its graph by using this information. Now students, it is also mentioned that fx is onto function. Now since it is an onto function, I can say a is equal to closed 7 to 35, because in onto functions the range is equal to codomain. Now students, we move further. Now students, we move to the function g of x. G of x is defined as x to the power 2025 divided upon 1 plus x to the power 2025. This can be further written as 1 plus x to the power 2025 minus 1 divided upon 1 plus x to the power 2025. This can be splitted as 1 minus 1 upon 1 plus x to the power 2025. Now the domain of function gx is given to us as closed 0 to infinity. So I can say 1 plus x to the power 2025 will be greater than or equal to 1 but less than infinity. So if I take the reciprocal of this quantity, it becomes greater than 0 but less than or equal to 1. Now just multiply this inequality throughout by minus 1. So I will be getting minus 1 upon 1 plus x to the power 2025 greater than or equal to minus 1 but less than 0. Right? Now just add 1 throughout this inequality to get the range of the function gx, and this value comes as closed 0 to open 1. So students, this interval becomes the range of gx. Right? Now since the function gx is also onto, so I can say the set B will be nothing but closed 0 to 1 open. Now we have to answer the number of elements lying in the set S. Right? We have to calculate n of S. Now S is defined as the set of all integers such that they either belong to the set A or they belong to the set B. Now students, let's find S first of all, and then we will be counting its total number of elements. Now students, the set S contains all the integers that are either belong to the set A or to the set B. Now in the set B, we have only one integer, and that is 0. And in the set A, we have all the integers lying in the interval closed 7 to 35. So that means it is 7, then 8, then 9, and so on till 35. Now just count the total number of elements. It is 29 plus 1. So this is 30. So I can say n of S is equal to 30. Now students, option C is the correct one. Now we move towards the next question. Now students, this is the last question of this video, and the question is based on the topic of vectors. It says, let vector A equal to I plus j plus k, vector B equal to 2i plus 2j plus k, and vector D equal to A cross B. If C is a vector such that A dot C equal to mod of C, square of mod of C minus 2a equal to 8, and the angle between vector D and vector C is pi by 4, then we have to find the value of the expression mod of 10 minus 3 into b dot c plus square of mod of d cross c. Now students, in this question, we do not know the vector c. So I am supposing the vector c as xi plus yj plus zk. That means we have to find the values of x, y and z. Now we have been given the vector a, we have been given the vector b. So we can easily find the vector d by taking the cross product of vector a and vector b, right? Now we have also been given these two equations. So if I start with square of mod of c minus 2a equal to 8, then I can further write this as c minus 2a dot c minus 2a equal to 8, because we know that square of mod a is nothing but a dot a. So now this becomes square of mod c minus 2c dot a minus 2a dot c. So this becomes minus 4a dot c plus 4 into mod a square equal to 8. Now students, mod a square is clearly 3, right? And a dot c is nothing but mod of c. So this equation becomes square of mod c minus 4 mod c plus 4 into 3. This becomes 12, and 12 minus 8 equal to 0, right? So the equation becomes mod c square minus 4 mod c plus 4 equal to 0. Now students, this can further be written as mod c minus 2 whole square equal to 0. So from here we get the value of mod of c, and that is nothing but 2. Fine. Now since mod of c is equal to 2 and a dot c is equal to mod of c, so I can write a equation in terms of x, y and z, and that becomes x plus y plus z equal to 2, right? So this is our first equation. Now students, we move further. Now students, since we have mod of c equal to 2, so I can say mod of c square is equal to 4, or I can say x square plus y square plus z square is equal to 4. So this is our second equation in terms of x, y and z. Now students, to get the values of x, y and z, we need 3 equations. We have got 2 equations, one more equation we need to find in terms of x, y and z. Now, first of all, we find the vector d, because vector d is nothing but a cross b. So the vector d will be equal to the determinant. In the first row, we will be having ijk. In the second row, it is 1, 1, 1. And in the third row, it is 2, 2, 1. Now the vector d becomes I into minus 1 minus j into minus 1 plus k into 0. So this is nothing but minus I plus j. Now students, we have got the vector d. Now let us find d dot c. Now it is given that the angle between vector d and vector c is pi by 4. So d dot c will be equal to mod d into mod c into cos of pi by 4. Now students, mod of d is nothing but root 2. Mod c we have already found, and this is 2 into cos of pi by 4 means 1 upon root 2. So this value becomes 2. Now what is the benefit of finding d dot c? We know that vector d is minus I plus j and vector c is xi plus yj plus zk. So from here another equation in terms of x, y and z comes, and that is minus x plus y equal to 2, or y minus x is equal to 2. Now students, this is our third equation. Now with the help of these 3 equations, we will be finding the value of x, y and z, and hence we will find the vector c. Now students, we have y equal to x plus 2. We have x plus y plus z equal to 2. So that means from here I can say z equal to 2 minus x minus y, or this can be further written as 2 minus x. In place of y, I can put x plus 2. So this becomes minus 2x, right? That means z is nothing but minus 2x. Now students, another equation which we have is x square plus y square plus z square equal to 4. So now just put y square as x plus 2 whole square and z square as 4x square and simplify this equation. So we will be getting 6x square plus 4x plus 4 equal to 4. That means we get 6x square plus 4x equal to 0. So we get 2x common. Inside the bracket we get 3x plus 2 equal to 0, or from here we get x equal to 0 and the another value of x is minus 2 by 3. Fine. So students, when x is equal to 0, I will be discussing two cases now. In the case number 1, we have x as 0, y is x plus 2, so y will be equal to 2, and z is minus 2x, so it is just 0. And in the case number 2, x is equal to minus 2 upon 3, so y becomes equal to x plus 2, means y becomes 4 upon 3 and z becomes minus 2x, so z becomes 4 upon 3. Fine. Now students, we will find the value of the given expression. Now students, let's consider the case number 1 first. In this case, the vector c becomes equal to 2j. Why 2j? Because x is equal to 0, z is equal to 0 and y is equal to 2. Now we have to calculate the expression mod of 10 minus 3 into b dot c plus square of mod of d cross c. Right? Now first of all, let's find the value of square of mod of d cross c. This becomes square of mod d into square of mod c into sine square pi by 4. Right? Now students, just put in the values. Square of mod d becomes 2, square of mod c becomes 4, and sine square pi by 4 is 1 upon 2. So the value of this part becomes 4. Now we need to calculate this particular expression, and to calculate this expression we need to find the value of b dot c. Now b is 2i plus 2j plus k and c is 2j. So the value of b dot c becomes just 4. Now if I put 4 over here, it becomes 10 minus 12 and mod of this value means the mod of minus 2. So mod of minus 2 is how much? It is 2. So 2 plus 4, the value of this required expression becomes 6. Now this was the first case. Now we move to the second case. Now in the second case, the vector c becomes minus 2 by 3i plus 4 upon 3j plus 4 upon 3k, right? Because here x is minus 2 by 3, y is 4 by 3 and z is 4 by 3. Now students, the value of the second part of the expression, that is square of mod of d cross c, will still be same because mod c is same, mod d is same. So this value is unchanged. That is, this value is again going to be 4. But the value of b dot c will change. Now b is 2i plus 2j plus k and c is in front of you. So b dot c becomes minus 4 upon 3 plus 8 upon 3 plus 4 upon 3. And this becomes 8 upon 3. Right? Now just put the value of b dot c as 8 by 3 in the expression. Now it becomes mod of 10 minus 8 plus 4. And this is how much? 2 plus 4, which is again 6. So that means the value of the required expression is 6 in both the cases. Now students, I am ending this video over here, and next video I will be posting very soon. So watch that video as well, which will contain another 25 questions from JEE Main Entrance exam of January 2025. So keep watching my videos and enhance your knowledge of mathematics. Thanks.